Hello everyone. Welcome to this machine learning session. In the previous session, we have seen how you are going to run linear regression using two columns. Those were years of experience and salary, where we have kept one input and another one was output, which was being converted into X and Y variables. Now we are going to see I have taken one more data set I have created, and this time I have done at least 100 entries, as you can see on the screen. Yes. Now, accordingly, what we are going to do, we are going to see how studies are going to impact the exam scores. So I'm just going to convert it in leniency so that it is going to be, yeah, and I'm going to just do this. Yep. Now you can clearly see how it is being arranged. Now, similarly, when you are going to see that 6.24 hours have approximate how much score it is going to get, 31.67. So these are individual scores. So what prediction we are going to do, if we are going to write study or hours, like study hours, we will be getting output as how much examination scores that student is going to get. So it is actually exam prediction or score prediction model, which we will be creating using linear regression. Previously, we have run the similar one using two columns only. This time I have created it. So accordingly, I want all of you, I request all of you to kindly create such kind of columns. You can keep the entries little more than the previous one, where you are going to see how examination scores are going to be impacted by study hours. Once you have created it, we will be getting ready to create the prediction model using all the same steps which we have taken in the previous session. If you remember, in the previous session, we have used four parts of it. Number one was you are going to import all the libraries. Second part was you are going to first of all, you are going to read that by using pandas. Then by using matplotlib library, you are going to visualize the pattern. Fourth point, you are going to analyze it. You are going to split the data into train and test. And then we are going to run the predictions and evaluate the model. Using all these five steps, we are going to create today's model also. And in today's model also, we will be using linear equations or linear regression. So let's quickly get started. And previously, we have used Visual Studio Code. So there are some students who were finding it difficult to get started with Visual Studio Code to actually install it in your system and then run the analysis. This time I'm going to do it on Google Colab so that you will get to see, you'll get a versatile environment, how you are going to use the similar code on different platforms. So students who are finding it difficult, let's quickly understand how you are going to set up a Google Colab. So I'm going to open a browser. You can choose any browser of your choice, and I'm going to write Google Colab. The moment you are going to click on this, that is collab.research.google.com, it is going to open in front of you. As you can see over here, if you wanted to get started with a new notebook, what you are going to do, you are going to click on File, and you are going to click on New Notebook in Drive, or open a notebook or upload a notebook. So all these options are there in front of you. Here it is like if you wanted to add a code, you wanted to add a text, and you wanted to run the entire code which you have written. Let me quickly explain the entire platform in front of you. If you wanted to connect any data, or you can say a data set from GitHub or anywhere, a different library, you can add and connect that also. Now over here, when you are going to click onto it, if you wanted to add any section in that, that is also you can do. If you wanted to search or find and replace, that also is that option is also available. This is about code snippets which you wanted to take. And then we have secrets which you wanted to, like if you have any key which you wanted to upload, that is also you can get help from. Now here is a folder. If you want to upload any file, suppose we are going to upload the data of examination scores and all. First of all, you have sample data. If you wanted to take and connect any sample data from it, so that also you can do. If you want to upload any data, you are going to click onto this option and you are going to take study hours and scores. So you are going to click OK. Now this CSV file is uploaded. Based on that, we are going to run our code. So let's quickly get started. We are going to follow all the same steps which we have done in the previous segment. So one by one, we are going to the first step which we will be doing. That is, we are going to upload all the, we are going to import all the libraries. So let's quickly do that. Import pandas as PD. Right? Second, we are going to do import Seaborn as SNS. Third, we are going to do import matplotlib dot pyplot as PLT. Then we are going to import from sklearn dot model. Now, the moment you are going to do that, now can you see that these are all already coming in front of you? So what you can do, you can just put this and it's all done in front of you. So that is what I have done. And once you have done this completely, the third part which you are going to do, import maths, and done. So these are all libraries which we have imported. Why we have done that step by step in the previous segment, I have already explained it. Now let's quickly do it. Let's quickly get started with how you are going to fetch and read that. So libraries we have done. I am going to put that and load data set by using pandas. So we are going to create a data frame. df is equals to pd.read CSV, and that CSV is going to be R, and I'm going to go to my data, which is this, click onto it, copy the path, and you are going to paste over here, right? So this is how you are going to upload it. Once you are done with that, you are going to print and see. So that you can see this. Now, once you are going to have the data in front of you, you are going to visualize this. Visualize the data or pattern. Now, what kind of pattern we wanted to show? So we are going to say SNS dot scatter pyplot. Let's see if we can do that. Scatter plot X is equals to, and this time like what I am doing for this scatter plot, it is going to give me a scatter linear regression part or a line on which I am going to find and visualize the pattern. So for that, I am going to do data is equals to df, and inside it x is equals to study hours. Let me see how is that. First of all, I have to visualize it. What is the X, whether there are capital letters or not, otherwise it is not going to read. Okay, so I'm going to do that. And then I'm going to put Y is equals to, I'm going to go again, exam scores. So this is what I'm going to do. Done. So make sure when you are going to define X and Y, it is actually case sensitive. So you are going to keep the values, whatever is written. If it is written in, you can say capital letters, you are going to keep it in capital letters. If it is being mentioned in small, you are going to mention the small. All right. Now you are going to give it a title, PLT dot title. And this time I'm going to show you how it is going to get started with. So I'm going to mention what study hours versus exam scores and enter. PLT dot X label. It is X label as study hours. I'm going to press this and this. So what I have done over here, I have defined what are the labels in the chart is going to mention when it is going to create a graph, what is going to show X and what is going to show Y. So similarly, we are going to create the chart. And now I'm going to show PLT dot show. And you are going to do this. Now, once you have done that, let's quickly run and see. Exactly. Now at the bottom, can you see this chart over here? This is how it shows the pattern. And you can clearly see a student who is actually like reading and studying for 15 hours. The score is higher as 80%. So these are actually in the percentage. So we can clearly see a pattern. Greater number of hours or more number of hours is increasing as more number of scores. Now let's see. We have visualized the data. Now we are going to split. Split the data. Now for splitting the data, what we have done, we have already imported test train split library. So that is what we will be using over here. We are going to define X is equals to DF and we are going to put over here, we will be putting study hours. Study hours and make sure that study hours when you are writing, it will be exactly in the same manner when you have defined. So S is capital and R's are capital. Otherwise, it is going to create an issue of that. DF and I'm going to mention exam scores. Score. All right. So this is what I have defined X and Y. Now we are going to convert that into train. X is going to be trained and train X test. All right. Similarly, we are going to put Y train Y test is equals to train test. We are going to call upon this method X, Y. Then we will be defining this test size is equals to, now still the data is really small. So we are going to make sure that we will be taking 80-20 ratio. Test size means it is going to provide 0.2 means 20% out of 100. So if we have 100 data means 100 entries. So out of that 20 columns are going to go for the testing part. So 2 and then we are going to define random state. I had already explained what is random state. Basically, random state is defined as whether you want to stick to one particular data set or not for testing. Otherwise, it is going to randomly take out of 100 any entry for the testing, which is going to create accuracy, which is going to hamper the accuracy of that prediction model, as well as it is going to hamper you can say the training and testing data as well, means basically the prediction of it. So this time let's create 40. You can take any number, it doesn't matter. All right. Now, once I'm done with this test and train, now I'm going to print. Print. So basically, print X test X test. Okay, and Y test. So similarly, I have put X test and Y test. When I'm going to run, it is going to show me that result. So let's quickly run and see. So here is PyPlot, and over here, if you can see, this is study hours. And if you are going to count all these entries are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So total you can say the data set which I have uploaded, it was 100. If we are taking 0.2, which is 20% for testing, it is going to take 20 entries. And accordingly, with study hours, like if someone is studying for 1.89 hours, the exam score is going to be 12.73. So you can see over here, 1 hour, 12.73. So similarly, it is taking these data, and that is the exam score. So accordingly, as of now, the data which we have done, that is absolutely up to mark, right? Now I'm going to put over here, shift enter. When I'm going to do that, there is another line which is going to come. Over here, what I'm going to do, now I'm going to train and predict. Now, why I have done this shift and enter? Because now I am shifting this entire part. This part was to visualize it. Now I'm going to train my data, and I'm going to actually see the difference between the actual data and the predicted data. So basically, we are running that thing, all right, the way we have done in the previous segment. So let's quickly do that. Over here, I have done. Now I'm going to call upon my model. All right. So what I'm going to do, I'm going to put model is equals to linear regression. So basically, I have called upon that model. This is the object which I have taken on the basis of this particular scikit-learn model. All right. This line is going to make sure that you are calling upon to run the mathematics behind linear regression based on the data set which you have uploaded. All right. And now I'm going to use a method model.fit. And what we are going to do, X train and Y train. So basically, with this model fit, what we are doing, we are training our X and Y. We are training the machine on X and Y. After this particular line, what the model is going to say that now I know each and everything. I have learned it. You just give me the data and I'm going to predict the score of that. All right. So what we are going to do now, we are going to put Y, basically Y predict. Now we are going to predict Y value of it, okay? And that is going to be model dot predict. And what we are going to predict on what basis? We are going to provide X test to it, and it is going to print the Y prediction. I predict. Okay, now it's done. Okay, now I am going to do print Y predict. Yeah. So this is the actual part. Now what we are going to do, now we are going to run the comparison of it. Okay. So first of all, let's quickly do that. Let's see how it is going to run. So basically you can see this is the Y predict. on the basis of the data X test. So anything like 10 is going to be the score, 16 is going to be the score. So accordingly, you can see the data. So Y prediction is ready in front of us. Now, so now is the time to calculate what is the actual and the predicted. So what we are going to do, we are going to compare both the values. So let me quickly create a comment. Compare actual and now, before that, I have done one more thing which we have done in the previous class. Because of the one dimensional, you might get one error. So first of all, before we run that actual and the predicted, we are going to convert our X, which is our input, into two-dimensional. Basically, not into two-dimensional, but we are going to drop exam score, which is on axis 1, so that we are going to get X value. So that is what we will be doing. So kindly make this change in your code. So now let's quickly print to do slash n for the next line. Actual, this is my actual value. So versus predicted. So that is what I'll be doing. Now, once I have done that, I'm going to write print pd dot data frame, and then I'm going to get started with it. That is what I'll be doing. Here I'm going to write actual. And this actual I'm going to keep in just single quotes, not double quotes. Yeah. Now over here, I'm going to put y test dot values. I'm taking values dot label so that I'm going to get the exact correct value. And then I'm going to get predicted. That predicted also I'm going to write in single quotes. And same thing I'm going to do y predict dot label and done. So this is what you are going to do. Once you will be running this entire code, you will get the values. Okay, I have made a spelling mistake. VAL. Okay, so I'm going to write this. Now again, I'm going to run. Now over here, pd.data frame print. It's the error. Okay, double. Now it's correct. Hope so. Yeah, now let's quickly run this. Yes, now can you see? 4, 0, 1, 2, 3, 4. These are 19, and we have taken the actual was 12, predicted was 10, actual was 65, predicted was 66, 52, 58, 46. So we can see that it is nearby. The precise value is absolutely accurate. So therefore, like only +1, -1 is the difference, not huge, as you can see over here. So therefore, now is the time where we are going to calculate the values, or you can say the error percentage. So let's quickly create that. Before we do that, let me quickly revise what we have done in today's class. We have actually worked upon this data, which is study score, and we have calculated exam scores based on study hours. So as over here, I have taken 100 rows. In 100 rows, we have two columns. These columns are dependent. The input is study hours and the output is going to be exam scores. You are going to understand in a manner. अगर आप किसी के स्टडी आवर्स को बताते हो कि मैं 10 आवर्स पढ़ता हूँ, राइट? तो मेरा स्कोर क्या होगा? So we have created a machine learning using linear regression who is going to predict exam score for you, right? And that is completely based on how much you are studying. So this is the model which we are creating using linear regression. We have taken only two columns. First of all, we created the visualization score of it. Let me quickly open that visualization in front of you so that you will get to see the pattern in that. Okay. So here is the pattern, as you can see in this particular chart, where you can see a straight line. When you are going to draw a line, it is going to be exactly straight. So we can clearly see that there is a pattern in that. Following that pattern, we have calculated the actual and the predicted value. Now, the rest part we are going to do in the next class, in which we are going to calculate the mean square error value, with which we are going to evaluate the error percentage in this, and we are going to see that how we are going to share this particular segment with our clients. So stay tuned for the next session and keep learning, everyone. Thank you.